Hey guys, it's Joe again, and I'm going to go over some more voltage divider stuff. I don't feel like I had explained it well enough. So basically, let's just leave off where let's pick up where we left off before. Before we found what VA and what VB means. Basically, I told you like it's like starting at the 20 volts and moving your way and finding what VA is and what VB is, and VB could be dependent on VA in order to find VA. So basically, I said that VB would equal to VA times your R equivalent over R equivalent plus 3. We ended up getting that VB was 6 volts. So let me show you guys basically what that means. I said that it's dependent on VA, and you might be wondering, well, what happened to the 20 volt source, or what happened to the 2 ohm resistor? Well, we already took that into account when we found VA. Basically, what we're doing is we're finding VA, and why VB is dependent on VA would be because if we were to redraw the circuit, and what that would look like is that we have some sort of voltage VA here, and I mean it can be like plus minus, it doesn't matter, and then it goes to, and this can be grounded at that point, and then it goes through a 3 ohm resistor, which now here's VB, as opposed to here there's like a 20 volt and 2 ohms. So now we're redrawing it for VA, what that might look like for VB, and then basically VB has some sort of R equivalence here. So basically what we want to do is find what our R equivalent is, so we can say R equivalent divided by 3 plus R equivalent. And then you multiply all that stuff from what we found what VA was. So basically, say we have a new node called, right here, called VC, and we already know what VB is equal to 6 volts from what we found last time. If we were to redraw the circuit, we would say that VC is equal to VB times R equivalent, which in this case there is no real R equivalent. The R equivalent is 4 ohms. That's the only thing that's left, which would be 4 ohms over 4 ohms plus 2 ohms, which is 6 ohms. So 4 plus 2. I'm sorry, 4 plus 2, which is 6. So if we were to plug in what VB is, which is 6, so we got 6 times 4 over 6. The 6's cancel, which means VC is equal to 4 volts. Alright, so let's go ahead and double check our work again in LTSpice. I want to show you guys, I had already drawn out the circuit and done a simulation, but I can go ahead and show you guys what it looks like. So in this case, we said at this point here, which we called VA, we found it to be 12 volts. So basically we found it to be 12 volts, and LTSpice agrees it's 12 volts. So we said VB was 6 volts. So let's go ahead and just double click on that little node there, and that's where VB was, and again it agrees, it's 6 volts. So we said VC was over here. If we double click on VC, we said it was 4 volts, and there it is, it's 4 volts. So even though I had drawn the circuit as a full circuit like this, basically we could also draw the circuit as an equivalence, which we can find here. So here's the equivalent circuits for VB would look like something like this. Like we have a voltage VA, and it goes through some sort of resistor, which is 3 ohms, and then there's some sort of R equivalent that we called for VB, and we found VB to be R equivalent over 3 plus R equivalent, and then you multiply that by VA, which is equal to VB. Okay, well now we have VB, which is equal to all this garbage here, whatever number this came out to, which we said was equal to 6 volts. Then we have another circuit, which we can say, okay, well here's VB, which is 6 volts, and it's going to go across a 2 ohm resistor, and there's some sort of resistor here, which is 4 ohms, and a ground. And we said this point here was VC, and then we said, alright, well VC is going to be equal to VB times our R equivalent, which in this case was 4 over 2 plus 4. So basically we got VC is equal to 6 volts times 4 over 6. And like we said before, the 6 is canceled, so VC is equal to 4 volts. And that matches exactly what we got on LTSpice. So again, I want to thank you guys for watching. I think next time what I'll do is go over some more things, maybe more nodal analysis on more complex circuits, so that way you guys can get an understanding of multiple voltages, so not just solving for VA. So basically there might be a VA and a VB, and I'll show you guys how to use nodal analysis in order to do that. Thanks again for watching, and I will talk to you guys later. Alright, bye.